Okay guys, next lesson is something called scatterplots. Pardon my messy handwriting there, I will try to do better. Scatterplots. I'm sure you've seen these before, but you're going to see them again, so it'll be a good little refresher to have a lesson with scatterplots. Where they usually come from is some sort of data. It could be anything. It could be temperatures as the day goes on. It could be the amount of money as you save it. It could be how weight as you get older, height as you get older. All kinds of crazy stuff. Let's just, for example, say we did the weight of a kid from the time they were 5 years old up to 18 years old. So maybe we have age and weight. So let's say maybe the 5-year-old, I have no idea how much a 5-year-old weighs, but we'll just make some guesses. Maybe a 5-year-old weighs 40 pounds. Then maybe a 6-year-old weighs 45 pounds, and maybe they start to hit their growth spurt and grow a little bit here, so maybe 10 was up to 70, 11, 77, and maybe at age 12 they didn't grow as much, and so on. I'm going to stop there because you probably get the point. Now, I could have you go in and plot all these points. Now, in the real world, most of the time, you only need quadrant number 1. In the real world, we usually don't have negative age, we don't usually have negative weight, things like that. So most of the time in the real world, we're over here working. So for me, for weight, because the first is always your X, second is always your Y. So I'm going to put the age out here across here. Now I started at 5. Now, if you have a whole bunch of a range here, a whole bunch of numbers, you may go up by 2s, you may go up by 5s, you may go up by 10s. You don't necessarily have to go up by 1s. We could have ages from age 5 up to age 75, and maybe you go by 10s. Maybe you'll have 10, 20, 30, 40, 50, 60, 70. I'm just going to make a chart. Up the side, I'm going to have weight, and I'm going to go by 10s here. So I'm going to start. I'm going by 10s. 10, 20, 30, 40, 50, 60, 70, 80, so. And then you just plot your points. This 5-year-old weighed 40 pounds. The 6-year-old weighed 45. 7-year-old weighed 48. 8-year-old weighed 52. 9-year-old was up to 60. 10 was up to 70. 11 was 77. 12 was 78, stayed about the same. And 13 was 81. So there is a bunch of dots, and this is called a scatter plot. Now, these seem like they're in a pretty good line. Sometimes you'll have dots just scattered absolutely everywhere. Sometimes you can tell if they're going uphill, sometimes you can tell if they're going downhill. Here's kind of what you're looking for. I'll give you an example. In this book, they give you samples, a bunch of scatter plots. Now, lines that tend to be going uphill, this. You can tell as you go across, they're going up, going up, going up. That is called positive correlation. And if you can see this chart here good, positive, positive, positive. Now, if your dots are in a perfect straight line, they call that perfect positive. Now, you'll see a number here. If you see the number 1, 1 represents perfectly straight line. And I'll tell you what 0 and -1 mean in a second. These dots are almost in a straight line. They're not necessarily perfect, but they're pretty darn close to being a perfect straight line. So they call it strong positive. And you notice that R value is 0.8. It's almost 1 because 1 means perfectly straight, so 0.8 is almost 1. If you think of money, this is $1.80, pretty close. These, you can kind of tell they're going uphill, but really they're kind of scattered everywhere, and it's not very good, not real close to being straight, so they call this weak or moderate positive. You can still tell it's going uphill, but not very much. So you notice that's a low number, like 0.3. 0 means there's no correlation. There's just no correlation between those dots. You can't tell they went uphill, downhill, what that even means. On the opposite side, negative correlation. I'm going to jump this one first. If they're going downhill in a perfect straight line, you call it perfect negative. And guess what? It's negative 1. 1 means a perfectly straight line. Negative means going downhill. These dots, pretty close to a straight line, but not necessarily. So they call it strong negative. Not perfect, but strong, so negative 0.8. These, you can tell it's going downhill, but it's almost at nothing. So they call that moderate or weak negative. So that's what we're looking for. If we go back to the one we just did, of the kids' age while they're growing up from age 5 to 13, what do you think that is? It's definitely going uphill because as you get older, from age 5 to 13, your weight goes up. And I know there's exceptions to every rule. You could have an 8-year-old that's really heavy. You could have a 13-year-old that's really light. Yes, there are exceptions to every rule, but overall, in general. Now, it's almost like we could say perfect positive, but it's not quite exactly perfect. So in this one, I would say strong positive. For this class, you're not going to need that number of 1, negative 1.8. But next year, your teacher may ask your opinion on that. Remember, a 1, think of $1, would be a perfect straight line. This is pretty darn near perfect. So if it was me, I'd say 90 cents or 0.9. So that would be something like that. This little squiggly means approximately, your guess. I'd say around 0.9. Almost perfect, but not quite. Now, I went to Google, and I did a search for the word scatterplot. And I got all kinds of scatterplots here. Now, they're very, very small. I'm going to zoom in and see what I can find here. And I'm going to be looking at the screen while you're looking at the screen because this is very tiny. So let's see how good this computer zooms in. There you go. Hopefully you're able to see that. Now, some of these will have the description of what the graph is. Some of them don't. But I just want you to look at the dots. These dots here, they seem to be going uphill, not perfect, so we call this strong positive correlation. You can tell they're going uphill, so I wouldn't say weak, so I'd say pretty strong. Here's one. This is temperature and sales. So think of some business that as the temperature goes up, they would make more money. In my mind, I think of maybe an ice cream shop. As it gets hotter outside, they're going to make more money. If it's colder outside, they're going to make less money. So maybe an ice cream shop, or maybe this is a place that sells drinks, because as you get hotter, you get thirsty. Now, I also call this strong positive. It's going uphill, not exactly perfect, so strong positive. Here, what do you think those dots are doing? They're going downhill. So I would say weak correlation, negative. Now, you could argue and say it's strong, negative. That's your opinion. I would take weak negative or strong negative. I can tell it's going downhill, but it's not exactly perfect and not even really close to a straight line. Now this next one, that thing's scattered everywhere. But you could argue that overall in general, it seems to be going uphill. So I'd call that some kind of positive. And let's see what else we can find. Here's another one. Find here. Height versus weight. Overall in general, as the weight goes up, the height goes up. If I took everybody in this class and lined up based on what they weighed, usually the people that weigh more are taller. And yes, there's exceptions to every rule. I kind of don't like that example. I'd rather have the other way, do height and weight. If I lined everybody up from shortest to tallest, the taller people usually weigh more. Just very quickly, you'll see sometimes I'll put a line through it. And this is just someone's opinion. They think this line here would be a good line to go through those dots. I think that's a pretty terrible example because to me, there is no correlation there. I can't see a correlation. Those dots are scattered everywhere. So I don't know why they put a line on that one. So that would be one I disagree with. That is, I don't know what thing is, surface temperature or something. Let's get up to a couple more so we can find. Here's some company's packaging control chart. So you cannot see that very well, but this sort of looks like on my paper, I can't tell what it says. But anyways, the dots are sort of going downhill. So I would say maybe some weak negative correlation. And here's another example of what I would say is no correlation. And there's another one now. I'd say it's going downhill, so I would say that's negative. So I think you probably get the gist of it by now. I'm going to look here and see if I can find a couple more. I don't see too many perfects in here. But like I said, you can find this, and I just went to Google, typed in scatterplots, and found it all. I actually have a poster in the back of my room on scatterplots. I'll take a picture of it and send it out with your work because it gives some more examples. And there's one more. Here is a negative correlation. And what your teacher will probably have you do next year, they'll have you pick a line that you think fits the data good. There is no exact perfect answer unless you use actually a formula that a computer can use that will actually take every single dot and figure out an average formula to get to the line closest. So you say, well, let me pick a line that would be very close to as many dots as possible. And there is an actual formula that the computer would use, but we're not worried about that in here. It's called a line of best fit. For our class, and probably even next year, unless your teacher gets out the computers and lets you do it, you're just going to use your opinion and draw a line that you think hits the data pretty well. So that is scatterplots. And what's going to happen today is you're going to be given, you're just going to have a bunch of pictures, and you're just going to talk about, is the scatter plot strong correlation, weak correlation, or none? And is the correlation positive or negative? So these are going to be the answers you're going to have for today's lesson on scatterplots. And just give you a quick example of what some of the problems look like. They may just give you a bunch of things like this, or they could give you some real life things. There is one on cigarette consumption by males and the deaths per a million from lung cancer. So lots of real life stuff. Now, in today's world, with everything that's going on here with the coronavirus, you probably see a different kind of plot. Now, this is not in your book. It probably won't be in your lessons unless I can find some. There is a kind of plot that's called exponential. Exponential means something starts out kind of low, it kind of grows a little bit, and then all of a sudden it explodes and takes off like crazy. And you've probably seen this with the coronavirus stuff. So an exponential chart just kind of hangs out, goes low, and all of a sudden explodes. That's why I've been talking about this social distancing stuff. And they'll say, well, if you're not doing any social distancing, maybe each of these dots is a day. Well, after 7, 8 days, you keep talking to people, and you could have the virus and not even know it because somebody at the store gave it to you. It's not that you're a bad person or anything like that, but you had the virus and didn't know. Keep talking to people, bam, takes off. Then you probably see a chart similar. It says, well, if you started social distancing and you only talk to 1 or 2 people a day, maybe for you, it's going up just a little bit. And yes, it will eventually take off. But the longer you can wait, you hear them telling you, the more cures they can come up with, the better treatments they can come up with. They can do a better job of getting people out of the emergency rooms. They call it flattening the curve, try to get it before it gets up high, maybe knock it off so it go out through here. So you've probably seen some charts, if you've been watching the news, that are exponential. And when they talk about flattening the curve, they're doing everything they can. So when this thing starts to take off, they want to level it out so it doesn't take off. Theoretically, if we did not treat this thing and people didn't do any social distancing, you could wipe out entire cities, countries, everything. If you read some of the history of the Spanish flu from back in the early 1900s, thousands of people, millions of people around the world died. I don't know the exact numbers, but it was bad. So you keep hearing them talk about flattening the curve. When this takes off, they want it to go quick going up. So that's what the social distancing is. So that is scatter plots. You have a lesson on that. Hopefully these examples will help you. If not, let me know. Go to Google, go to YouTube, see what you can find.